Dear students, good morning. Greetings from IIT Tirupati. Welcome to the online lecture series on machine learning for image processing. I am Ramakrishna Gurti, Associate Professor in Electrical Department IIT Tirupati. I work in the areas of image processing, computer vision, machine learning, and deep learning. Let's have an overview of the course on machine learning for image processing. This video lecture primarily introduces the course and gives an overview of machine learning for image processing course. This is offered to electrical engineering students and any undergrad and first year postgrad students at IIT Tirupati. This can suit the undergrad final year and pre-final year undergrad students of different streams encompassing electrical engineering, computer science, information technology, and those who are interested to learn more on image processing and machine learning. The students in the first years of their degree in electrical engineering or in computer science can also do this course. The prerequisites that are required to understand the topics of this course are primarily the mathematical basics in linear algebra, probability, and calculus. I will be discussing briefly on the mathematical details, and the course has 10 modules. The first module introduces and gives an overview of the course. It introduces different elements of the course, such as it distinguishes the course from other courses like purely machine learning based course or image processing based course or deep learning based courses. Then I will give essential details of mathematics basics that are required to understand the course content better. It touches upon the linear algebra, vector calculus, and probability or random variable based basics for understanding the subsequent topics of this course more thoroughly. The classification methods or the machine learning based methods are started with statistical classification, primarily introducing it through probabilistic modeling of the class conditional densities of the samples that are to be classified into different classes, and that is majorly dealt through Bayesian classification. Subsequently, I will be discussing about parametric techniques or parameter estimation techniques to estimate the parameters of these class likelihoods more effectively with the real samples that are at our hand or the training samples at our hand. This course not only touches upon the machine learning aspects, but it also tries to give a application overview and application knowledge of the machine learning concepts in image processing. Thus, I will be introducing a basic some building blocks of image processing and discussing more details on the image feature extraction. As some of you who know the basics of machine learning knows that feature extraction forms a very important stage, and feature extraction from images has been focused very well in computer vision, and some details, essential details of it will be mentioned in that module. Subsequently, the determined features, which will be of very large dimension in most of the fields, are to be brought to reduced dimensions for effective or computationally efficient classification. So I will be discussing some of the video lectures on dimensionality reduction or using the classification techniques in reduced dimensions. In some sense, it's close to feature selection as well. Subsequently, I will be discussing the well-known machine learning method, that's neural network based classification methods, in more details. That forms in some sense the core of this machine learning for image processing course. And the earlier topics that I would have discussed by that time connects nicely through this machine learning or neural networks based classification. So you will be able to know by then how to process images and how to extract features from images, how to apply classifiers like neural networks or even Bayesian classification on some of the image processing or image classification tasks. Subsequently, we'll be discussing some details of unsupervised classification, which will help in applying the grouping of different samples in the in unsupervised manner, and that the applications of that on image processing, such as image segmentation, will also be discussed. I will also be discussing on regression, which also forms a kind of different estimation technique or applying the neural networks for a prediction or the estimation of the real variables. The course concludes with the discussion of some of the basic understanding of convolutional neural networks and the understanding of applying convolutional neural networks for image classification. So in this course, essentially, we are targeting the applications on image processing. The applications that we target are classification-based method applications. Let it be classification or recognition, which has wide variety of applications of computer vision, and the methods that can be used for performing these image processing and computer vision based applications, namely classification and recognition more specifically, are through machine learning based methods. And these machine learning based methods include both statistical machine learning based methods as well as discriminant function based machine learning based methods. The examples for each of them are Bayesian classification and neural networks. And this forms one of the very important base for understanding the convolutional neural networks based methods, and also to, in general, to appreciate all the current machine learning methods and the deep learning based approaches. So convolutional neural networks are also introduced to the level that you will be able to develop or apply the existing convolutional neural networks for your research or the application in mind. So the references that I will be using mainly are from machine learning and image processing or computer vision, and there are some reference books also encompasses in these areas. So pattern classification by Dodon and Hart, which is a very classical textbook for pattern classification and image machine learning, is used. In that, Bayesian classification and neural networks are the topics from that book I will be taking or discussing more upon. Richard Sigelski Computer Vision Algorithms and Applications book will give you an overview of feature extraction methods that I will be discussing from image processing. The other books, Gonzalez and Woods, will give you basics of image processing, and deep learning books by Godfellow will give you more details on convolutional neural networks. If you have any queries, feel free to write to me at rkc@iittp.ac.in. Thank you.